How can you find the area enclosed by the ellipse, which is the given equation, the b squared x squared plus e squared y squared is equals to e squared b squared? Okay. So by the way, when you say ellipse, so it consists minor axis and the major axis, or uh, if we figure out, or we can draw the ellipse, no? So the ellipse would be look like this. Okay, so we put in this Cartesian plane. Okay, so the minor axis is our, or we indicate the variable of a, then the major axis we indicate the variable of v. Okay, so if we put the vertical strips on this plane, or on this symmetry of ellipse, so we indicate here the width of the strip, that would be equals to the x. Okay, so the height or the length of the strip, that would be equal to y. Okay, so therefore we can formulate the area, or which is dA is equals to y dx. Okay, so integrate, so therefore this, the integral of d, that would be a, and that is equals to the integral of y dx. Okay, so since we indicate or y with respect to dx, so we all know that the our limit as an x values. Okay, or x sub 1 and x sub 2. So to locate this y equivalent, so we proceed to the given equation. Okay, since our equation is b squared x squared plus e squared y squared is equals to a squared b squared, no? So we can equate to find the equivalent of y. Okay, so first e squared, then y squared, so that would be equals to the b minus, or okay, or we can write first the e squared here, then we have b squared, then we can subtract b squared, then times x squared, no? Okay, so we can now divide both sides, e squared, so this is also e squared, then we have y squared, that would be equals to e squared b squared minus b squared x squared over e squared. Okay, so in order to eliminate the exponent of y, which is 2, so we can take the square root, no, both side. So therefore we can now cancel out this, and then we write y equivalent, no? Okay, so that would be equals to when you simplify this, take note, no, we have two terms. Okay, so we have the same b squared, then the second term, which is the coefficient of x squared, which is b squared, no? So we can out, no, b squared. Okay, so therefore b squared over e squared here, 10 times, or the square root of b squared over e squared times the e squared minus x squared. Okay, so next, so we can also simplify this, so we have the square root of b squared over e squared, okay, times the square root of the quantity of e squared minus x squared. Okay, so you see, this would be the square root of b squared over square root of e squared, okay, times the square root of quantity of e squared minus x squared. Okay, we can cancel both side, the square root or the radical symbol, no? Okay, so then we take the b over a, then the square root of e squared, then minus x squared. Okay, so that would be the equivalent of our y. So we can now substitute this in our formulas of areas that can be our formulated, no? So we have y that would be equal the equivalent of b over a to the square root of, or multiply by the square root of e squared minus x squared. Then we have the x here. Okay, in this case, let us or let x would be equals to e sine theta. Then we can now derive to, in order to get the dx. So where dx here, that would be equals to a cosine theta d theta. That would be equals to the integral of b over a, and then the square root of e squared, then minus quantity of a sine theta squared, then the a cosine theta d theta. Okay, so we have a over a, the integral of we can now factor out the or we can simplify this inside the square root, no, which is e squared minus the quantity of e sine theta squared, no. So this would be equals to e squared, or the square root of e squared times the square root of 1 minus sine squared theta. Then we have a cosine theta d theta. So take note that the sine, or the Pythagorean relation, which is the sine squared x plus cosine squared x, that would be equals to 1, or cosine squared here, or cosine squared x, that would be equals to 1 minus sine squared x. Okay, so let us now put something our equivalent of cosine squared x. So we have b over a, so this would be the radical symbol here, it would be cancel out. Then we have b over a times a, then the integral of square root of the cosine squared x, sorry, not x but theta. Okay, so we have a, then cosine theta d theta. Okay, then next we can now we remove the radical symbol, 2, and also this 2, no, or we can cancel out. So we have b, this would be b, no, Okay, or A then B. Okay, so the integral of the cosine theta then cosine theta d theta. So cosine theta times cosine theta, that would be equals to cosine square theta d theta, no? Equivalent of cosine squared theta, that would be equals to 1 plus cosine 2 theta, no, over 2. So let us substitute a times b, then the integral of 1 plus cosine 2 theta over 1/2. Now integrate, no? So we have a and b over 2. Okay, so the integral of 1 or the quantity of 1 plus cosine 2 theta. Okay, then d theta. So it would be a of times b over 2. Then we have the quantity of theta plus cosine 2 theta. Okay. So by the way, let's assume that x is equals to 0. So in this case, x is equals to a sine theta. Okay. So again, when x is equals to 0, so therefore theta also 0. Okay. So when x is equals to 1, so therefore 1 is equals to then we indicate a also is equals to 1, so it would be sine or 1 is equals to sine theta, or we have to find theta here, that would be equals to sine inverse 1, so that would be equals to the shift sine inverse 1 or 90. So we can convert 90 degrees to radian, so it would be pi over 2. Okay, so again we set the limits, which is from 0 to pi over 2. Okay, so we have a b here over 2, then substitute the upper limit, so we have pi over 2, then plus cosine 2 times so by the way, I forgot to integrate the cosine 2 theta here, so this would be equals to the sine 2 theta. Okay, so the derivative of 2 theta, that is 2 d theta, no, or the integral of the cosine 2 theta, that would be equals to sine 2 theta over 2. Okay, so again I just forgot to integrate the cosine 2 theta, no. So again, cosine 2 theta, that would be equals to sine 2 theta over 2. Okay, so let us now proceed. We have sine 2 theta, or where theta or the value of theta is in radian, so we have 2 times pi over 2 then over 2. Okay, so I get the bracket, then we have minus 0 plus sine 2 times 0 over 2. Okay, So in this case, that would be equals to 0. Then we have we focus on this, no? So to calculate, so we set the calculator into region mode. Okay. So we have here which is shift pi over 2, then plus the sign 2 times pi over 2. Okay, then over 2, so that would be equals to pi over 2. A times b over 2. Okay, times pi over 2 equals to pi a times b over 4 of the ellipse. So this would be the areas of the equivalent areas be the result of pi AB over 4, no? So therefore we have the 4 symmetry here to find. Okay, so since we have 4 symmetry to find, let's multiply this by 4, no? Okay, in order to get the area of the whole ellipse or the plane areas of ellipse, no? So therefore our plane areas of the ellipse, that would be equals to pi AB. Okay, so that is the final answer.